Here's another example. This time we're finding P and Q such that there is a unique solution, there are infinitely many solutions, or there is no solution. And here are the equations in matrix form. Now, for there to be a unique solution, the determinant of the matrix on the left can't be 0. And finding the determinant to be 12 minus 6q, you can see that the determinant will be 0 when q equals 2, which is not what we want. So for there to be a unique solution, q cannot equal 2. And the flip side of this is that for infinitely many solutions or no solution, q has to equal 2. And this is just the same set of equations, but this time we've subbed 2 in for q. Now, for there to be infinitely many solutions, we have to show that one of these equations is made up of the 2 other equations, i.e. one of the rows is a linear combination of the other 2 rows. So we're going to try some row reduction. So the first thing we're going to try is multiplying row 1 by 3. And the other rows in the matrix, row 2 and row 3, have remained unchanged in this step. Next, we are going to take away 4 lots of row 2 from the row that we just multiplied by 3. So we're going to take 4 lots of row 2 from the new row 1. And again, we're leaving row 2 and row 3 alone in the matrix. They stay the same. After doing that, our new row 1 looks like our old row 3. Nearly. What do we have to make P so that the new row 1 is identical to row 3? And the answer is that P equals -4. So for there to be infinitely many solutions, Q has to equal 2 and P has to equal -4. And this is because this is the necessary condition for one of the equations in the system to be a linear combination of the other equations. In this case, we found out that row 3, or equation 3, is actually equal to 3 lots of equation 1 minus 4 lots of equation 2. So row 3 equals 3 times row 1 minus 4 times row 2. And that's only the case when Q equals 2 and P equals -4. And so for there to be no solutions, Q equals 2 and P can't be -4. So P can take on any other value apart from -4. And like we said earlier, for there to be a unique solution, Q can't equal 2. That way the determinant is not 0. And I've just added some more explanations there. So for there to be infinitely many solutions, you want the determinant to be 0, and you want to find out how you can make 2 of the equations into the third using row reduction. For there to be no solutions, you just want the determinant to be 0, but you want to make sure that you won't have infinitely many solutions, so 2 of the equations cannot be combined to make the third. And then for there to be a unique solution, you just want the determinant not to be 0.